Hello, this is another video on current electricity. In this video, we are going to consider electric circuits. So we have a discussion on electric circuits and introduce Ohm's law. Now, an electric circuit basically is a path along which current flows. So if it's a closed circuit, current flows around the circuit. But if it is an open circuit, so current does not flow. So I will show both of them in a minute. So what are the basic things that you will have in a circuit? The first is that you must have a voltage source, which is represented, it could be a battery or it's a single cell. So this is a cell, and also you can have a resistor that is connected in series to that. It's possible. You can also have it in parallel. Then you have an ammeter that measures the current that flows through the conductor. Then you can have a switch that determines whether current will flow or not. And you can have a voltmeter that will be connected across the resistor to measure the potential difference across the resistor. So this is resistor R, and this resistor has a resistance of value R. Then this cell, we have a PD, or this cell we have an EMF, basically. So which is the voltage or the potential difference across the cell when it is not delivering current to the circuit. So in principle, this E will be equal to this V if the cell itself does not have internal resistance. We are going to talk about internal resistance later on. So let's say the EMF this time around is equivalent to the voltage. That's this V is the same thing as this E if there is no internal resistance. Now, this is an open circuit if this switch is open. That means current will not flow. This ammeter will not read anything. So this is an ammeter. Let me label them. This is a voltmeter. This is a resistor. And this is a cell. And this is a switch. So when this switch is closed, when this is pressed against it and it becomes closed, then current flows. So current flows from the positive terminal of a battery, of a cell or battery. This is a positive terminal, and this is a negative terminal. Okay, so current always flows from the positive terminal like that. Why? Because that is the direction in which conventional current flows. Although electron flows from the negative terminal, so electron, let's say you have a loop and this, you have a conductor, so you have an ammeter, you have a conductor, you have a voltage source. This is the direction in which electron will flow. Electron flow is from the negative terminal, while current that will be detected by this ammeter is called conventional current, and it moves in opposite direction to the direction in which electron flows. So electron flows like that, but current flows like that. So conventional current, you need to get that right. So don't worry too much about that, about the details, but what you need to note here is that your arrow has to point from the positive terminal of the cell like that. It has to go like that, not like that. Okay? Because that current here, I, is what will be detected by this ammeter. Okay? So that's the basic component of an electric circuit. You have a voltage source that will have a particular EMF, and you have a resistor. It could be single resistor, it could be more than one resistor. Then you have an ammeter that measures the current that flows. Remember, ammeter is connected in series. You can see it's connected to the resistor in series and to the cell. And while the voltmeter is connected in parallel, you can see, you can identify a node or a junction here. You can also identify another node or a junction here. So that's how you determine parallel connection. Now, let's go to Ohm's law. Ohm's law. Ohm's law is very fundamental in electric circuits. So it is a formula that is used to determine the current that flows through the circuit. It gives a relationship between voltage, current, and the resistance in the circuit, the total resistance, basically. Now, if you have to state the law, how do you state the law? Ohm's law. So Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference. At both ends of the conductor, provided temperature and other physical properties of the material remains constant. Other physical properties remain constant. So we know that resistance changes with temperature. That's why it's important that we are looking at constant temperature. So Ohm's law states that the current will be proportional to the potential difference. That is, V proportional to the current. Potential difference is proportional to the current. What does that mean, proportional? It means that when one increases, the other one will also increase. If this is a direct proportion, we've done this in mathematics variation. So it shows that when voltage increases, the current will increase. When the voltage in the circuit, that is the voltage source, increases, what we expect is that the current should also increase. Now, to get rid of the sign of proportionality that you have there, you introduce a constant. V, it will be equal to IR. So the constant of proportionality here that we introduce is known as the resistance, where R is the constant of proportionality called the resistance of the conductor. So that's the formula, V equals IR. This formula is very, very fundamental and very useful. So V is measured in volts, that's the voltage or the potential difference. I is the current that is measured in amperes, and R is the resistance that is measured in ohms. So that's the units. Volts, amps, and ohms. Okay. So how do you now there's something we have to check before we go to examples. If you plot a graph of voltage against current, so because you can see that voltage is proportional to current, it means that if I have on the vertical axis, for example, I have V in volts, and I have I in amps on the horizontal axis, I'm going to have a straight line that passes through the origin. Why will it be a straight line that passes through the origin? It looks like Y equals mx plus c. But this time, there's no c. If V is Y, that means if I plot voltage on the Y-axis, and I plot I, which is current, on the X-axis, so you can see current is my X now, then voltage is my Y now, then it means that whatever I have beside the I, which is the coefficient of the I, will be the resistance. If you map this to this, so M will be equal to R. It means that if I have a plot of V against I, whatever I get as the slope of this line will be the resistance. So if you have data for voltage and current, let's say you have a data that shows current, voltage and current, you have some values. If you plot this data and you have a straight line that passes through the origin, then you know immediately that the slope of this line will correspond to the resistance. Slope equals the resistance. And because you can see it clearly from y equals mx plus c, because there is no intercept on the y-axis because it passes through the origin, then c will be 0. So this part will not be there. That's why we have it as v equals IR. Okay. Now, if you, for example, invert one of these variables, let's say you invert, you plot v against 1 over I. So what do you think will happen? If you plot v against 1 over I, let's say again 1 over I, then you turn the graph upside down. Then you have something that looks like that. Okay, so the graph will change. So let's look at some examples. Example 1. Calculate the current of I in the circuit. In the circuit below. So we have a voltage source here. Then we have a resistor. And you have an ammeter that reads the value of the resistor. So if this is 6 volts and this is 3 ohms, and you have to calculate the current that is flowing I. This is a closed circuit. Though I'm not showing the switch, but it's closed. There's a complete flow or connection of path through which the current flows. Now, what do? This is very direct and easy because we know the V as 6 volts, and we know the R, which is resistance, as 3 ohms. Then I can get the current from Ohm's law. V equals IR. This is Ohm's law. Then by make I the subject of the formula, so it will be V over R. So I will be, what is V? 6 divided by, and the resistance 3. And yeah, so I will go 2 amps after it. So that's the current. That's how you calculate that when you have voltage and resistance. Okay. Now, but you need to know before the end of this video that the R you see in Ohm's law is actually the total resistance. This R is actually total resistance, which means when you have more than one resistors, for example, you have a series connection of resistors, you have R1 and R2, you have to combine these two resistances into one before you can apply this formula. Okay, so we'll look at series circuit and parallel circuit in the next video. So I'll see you in the next video. Bye-bye.